So in 6.4, we were simplifying radicals. Now we're going to do operations with radicals. And we're also going to find that when we simplify, unlike in 6.4, there's going to be some stuff left over inside the radical. Okay, so for part A, I'm going to first break down what's on the inside. So if you break down 16, you get 2 to the 4th. All right, so remember what we did in the last lesson? We always took the exponents on the inside, and we divided them by the index. So first of all, the cube root of -1 is just -1. So the cube root of that negative sign is just going to be -1. So on the outside, I'm going to write a negative sign. Now I'm going to take 4 and divide by 3. 4 divided by 3 is 1. So 1, 2 comes out. 4 divided by 3 is 1 with 1 left over. So we have 1, 2 out front and 1, 2 on the inside. 5 divided by 3 is 1 and 2 leftover A's. 7 divided by 3 is 2 with 1 left over. So I'm just going to rewrite it, making it look nicer. This is -2. Oh, and I forgot the index. -2 AB squared cube root of 2A squared B. And let's check, do we need absolute value? We do not. You don't need absolute value when the index is odd. Okay, part B. So I'm going to break this down. This is 4th root of 2 to the 4th, A to the 12th, B to the 13th. We're going to divide. So 4 divides evenly by 4. That's going to be 2 to the 1st, or just 2. 12 divided by 4 is A cubed. And now 13 divided by 4. 13 divided by 4 is 3, but with 1 left over. So on the inside, we have 1b left over. All right, let's check for absolute value. The index is even. Did any of the exponents go even to odd? For A, the exponent went from even to odd. So here's our answer. 2 absolute value of A cubed times B cubed, and then 4th root of B. Okay, for a quotient, I'm going to break this up into 2 different radicals. So we can simplify the top. The top would be x cubed. However, we need absolute value because the exponent went even to odd. On the bottom, we can bring y cubed out, and then a y has to stay inside. And the reason is 7 divided by 2 is 3 with 1 left over. So y to the 3rd comes out. The leftover y has to stay inside. You're not allowed to leave a radical on the bottom. So we multiply top and bottom by radical y, and we get our answer, absolute value of x cubed, radical y, over y to the 4th. Radical y times radical y is y, and then we multiply that with y cubed and get y to the 4th. So here's our final answer. Okay, for part D, break it up into 2 radicals, 4th root of 6 and 4th root of 5x. Okay, there's nothing to simplify. You could only simplify if you have 4 of something on the inside In the numerator, we have a 2 and a 3. In the denominator, we have a 5 and an x, so we don't have 4 of anything. So now we just need to rationalize the denominator. So here's a common mistake. Common mistake is people think we multiply by 4th root of 5x. When the index is 4, you need 4 of something to bring it out. So we actually need 3 more 5s because we only had 1. We also need 3 more x's because we only had 1. And if we do it to the bottom, we also have to do it to the top. So the numerator is going to become the 4th root of 6 times 125. That's 750. X to the 3rd. And we can't simplify that because where did 750 come from? 750 was a 2, a 3, and 3 5s. So we had a 2, a 3, and 5, 5, 5. We did not have 4 of anything, so we cannot simplify there. Okay, and then on the bottom, now we have a total of 4 5s, so a 5 can come out. We also have a total of 4 x's, so an x can come out. Do we need absolute value? Doesn't look like it. The exponent for x went from 1 to 1, so it didn't go even to odd. Okay, for number 1, I'm going to break down 54. So a few ways to do this. You could completely break it down. You could break it down into prime factors. So 2 times 27, and then 27 is 3 cubed. So the index is invisible. The index is an invisible 2. So we need 2 of something if we want to bring it out. So we only have 1 2, so that has to stay inside. We have 3 3s. So what is 3 divided by 2? It is 1 with 1 left over. So this is going to become 15 radical 6. (32) is 2 to the 5th. And now I'm going to divide all the exponents by the index. So we're going to have 1, 2 out front, and 1, 2 has to stay inside. 5 divided by 4 is 1 with 1 left over. 9 divided by 4 is 2 with 1 left over. And 20 divided by 4, that goes in evenly, that is 5. All right, so I'm just going to rewrite that answer without the super long radical. 4th root of 2a. Okay, let's check for absolute value. A started out odd, don't need it there. B went from even to odd, so we need absolute value on the B. (75) is 3 times 25, and 25 is 5 squared. This is a regular square root with an index of 2, so that means if there's 2 of something, 1 can come out front, so 3 has to stay, 5 can come out, x squared can come out, and then 7 divided by 2 is 3 with 1 left over. So we have 5x squared y cubed, radical 3y. We don't need absolute value, because none of the exponents went even to odd. All right, let's break this up into two radicals. And I'm going to simplify at the same time. So on the top, we can bring a cubed out. And we would need absolute value for that. We can bring a single b out. And then one b would be left inside. All right, what's the square root of 98? Well, 98 is 49 times 2. So the square root of 98 is 7 radical 2. And now we just need to multiply top and bottom by radical 2. So we have absolute value of a cubed. We have a b by itself, and then in the radical we have 2b. And then the denominator is 7 times 2, which is 14. Okay, for number 5, let's break it up. So what is 5 divided by 3? 5 divided by 3 is 1 with 2 left over. And q divided by 3 is 1. All right, on the bottom, we have cube root of, I'm going to break down 40. 40 is 8 times 5, or 2 cubed times 5. So I haven't simplified the bottom yet. The bottom becomes, so let me simplify the top as well, pq, cube root of p squared. And then on the bottom, we have, so we can bring a 2 out, but the 5 has to stay on the inside. All right, to simplify, remember if the index is 3, you need 3 of everything. So we have 1 5, we need 2 more 5s. And we have to do that to the top as well. So this is going to become P, Q, and then on the inside of the radical in the numerator, we have P squared times 25, or 25P squared. In the denominator, we have 2 times 5. So what's 2 times 5? 2 times 5 is 10. We're able to turn those two radicals into just 5 because there's exactly 3 5s underneath the cube root. Okay, for number 6, let's break this up into two radicals. I'll do that now before I simplify anything. So we have 4th root 8b. Nothing can come out there anyways because 8 is 2 to the 3rd. And we have 4th root of 3a squared. So remember, you don't just multiply by the radical on the bottom. That's only if it's a regular square root. We want 4 of a kind, so we need 3 more 3's, and we need 2 more a's. So we do the same thing to the top. 3 to the 3rd a squared. The numerator is going to be 8 times 27. That is 216. And a squared b. The denominator, well, we have four 3's, so a 3 can come out. We have 4 a's, so an a can come out. All right, let's check for absolute value. Looks like A went from even to odd, so A needs an absolute value. And, well, B never came out, so B doesn't need an absolute value. Okay, on the back, there's no more variables. We're going to learn how to combine like terms with radicals. We'll have addition, subtraction, multiplication, and division. So for the first example, radical 50 is the same as radical 25 times 2. So try to think of perfect squares that go into the number. If you could figure out the biggest perfect square that goes into the radicand, then you don't have to do a tree completely breaking it down. So I would make 500 100 times 5. Then I would make 125 25 times 5. So if you can identify the biggest perfect square that goes in the radicand, this will save you some time. So this is going to become 2, and then square root of 25 is 5. So 2 times 5 rad 2 plus 4 times 10 rad 5 minus 6 times 5 rad 5. So this is 10 radical 2 plus 40 radical 5 minus 30 radical 5. 10 rad 2, we can combine like terms. 40 rad 5 minus 30 rad 5 is 10 rad 5. And the correct order for these is actually the smallest radicand first. So 2 is smaller than 5, so rad 2 goes before rad 5. All right, we're going to FOIL on part B. So this makes, well, rad 3 times rad 3 is just 3. So this is 2 times 3, which is 6. Over here, you multiply the front numbers together, you get 4. Then you multiply the inside numbers together, and you get 6. For the inside, you do negative 4 rad 6. And for the last terms, we get negative 8. And then rad 2 times rad 2, we don't need the rad anymore. The rad cancels out. All right, these cancel out. We're left with 6 minus 16, which is negative 10. All right, when dividing, similar to when we did this with complex numbers, you're going to multiply by the conjugate of the denominator. So multiply by 3 minus rad 5. The denominator is the easy part. When you're multiplying conjugates, you don't have to FOIL. It's just 3 times 3, and then the radical times the other radical, so that would be negative 5. You have to FOIL on top. So on top, we get 6 minus 2 rad 5 minus 3 rad 5, and then plus 5. So the top becomes 11 minus 5 rad 5. And this is all over 4. Okay, radical 20 is, well, 20 is 4 times 5. So this is 2 rad 5. 125 is 25 times 5. So 5 rad 5. 45 is 9 times 5. Square root of 9 is 3. So 3 rad 5. Now we're just combining like terms. They all have the same radicand. So 2 plus 5 minus 3 is 4. So our answer is 4 rad 5. Okay, so multiplying here. You can multiply because they all have the same index. So this is going to become the cube root of 8 plus the cube root of 24. Now we can break these down. The cube root of 8 is 2. Then for this one, well, we know 8 is a perfect cube. So changing 24 to 8 times 3, we can bring this out. That's a 2. So it's 2 cube root of 3. Because 8 is just 2 times 2 times 2. So if you have 3 2's, you can bring 1 2 out front. All right, on number 9, we're going to FOIL again. So that's 18 times 3. Rad 3 times rad 3 is just 3. This is plus 6 radical 6 minus 12 radical 6. And that's minus 4. And then rad 2 times rad 2 is just 2. So we have 54 minus 6 rad 6 minus 8. 54 minus 8 is 46. Okay, for 10, let's first simplify what we can. 48 is 16 times 3, so that becomes 4 rad 3. 75 is 25 times 3, so that becomes 5 rad 3 over 5 rad 3. So in the numerator, we have 20 rad 3 plus 5 rad 3, which is 25 rad 3. We have 5 rad 3 in the bottom. The rad 3's cancel. 25 divided by 5 is 5. All right, I'm going to try a different technique here. So when I distribute this, this becomes 2. And then in the radical, I'm not going to multiply 3 and 15. I'm actually going to break down. So 15 would be 3 times 5. And so if you do it this way, it's a lot easier to figure out how you would simplify it. And then I'm going to multiply this. So there's a 2 out front. So I have the 3 that was in the front already. 60. 60 can be broken down. So I want to try to make pairs when possible. So 60 is 3 times 20. All right, so I could bring one of those 3's out front, and I'm left with radical 20 on the inside. Radical 20 is 4 times 5. So this is 6 rad 5 plus, so this is 6 times 2, which is 12 rad 5. Adding those together, 18 rad 5. There are a lot of ways to do this, as long as you get to the same final answer. Your method is fine. All right, last one, number 12. So we're going to multiply by the conjugate of the denominator. Remember, conjugate is when you keep the front the same, but you change the back. the denominator. You don't have to FOIL the denominator. It's just 1 times 1, and then negative 2 rad 3 times positive 2 rad 3. So that would be 4 times 3, which is 12, but it's negative. All right, FOILing the top, we have 5 plus 10 rad 3 plus 3 rad 3, and then 3 rad 3 times 2 rad 3 is 6 times 3, or 18. So this, the front makes 6, and then the radicals together make 3, so that makes 18. All right, so combining like terms, we get 23 plus 13 rad 3 over negative 11. And I've mentioned that I don't like negatives in the bottom of a fraction. So I'm just going to move the negative out front. Okay, that's all for 6.5.